All right, I guess we'll get started. Hello, good morning, everyone, and welcome to the Intro to Python workshop. Krish today is our workshop host. So, a little bit about him: he's an aspiring engineer from the Greater Toronto Area, and he's interested in spreading computer science literacy and has years of experience teaching students how to code. So, without further ado, I'll pass it on to you, Krish.
Yeah, let's get started. Yeah, so before we begin, let's quickly go through what we're going to cover today. As you can see, today we're going to go through the Hello World program first. Then we're going to go through data types, variables, lists, conditionals, and loops. And the way I've made this presentation is that it's pretty interactive. So if you want to follow along in your own code IDE or editor, yeah, feel free to do so. Uh, so the way the presentation is going to work is there's going to be content to read, just like you would have with a slideshow. But then there's also going to be some like live coding stuff where I'm going to actually code in front of you on the screen to show you how a particular concept works. So yeah, so that's how the structure is going to be. Let's get started. So we'll get started with the Hello World program to start off with, and then we'll go on to the further topics from there. So before we begin, I just wanted to quickly talk about the tools that we're going to be using today. So of course we'll be using Python since this is a Python workshop. And specifically, I'm using the code editor Visual Studio Code, VS Code. For beginners, I recommend VS Code for Python. I think it's really friendly to get up and running with. And yeah, I think this would be a recommendation for what to use. And in fact, this presentation I'm delivering from VS Code, as you could probably already tell. So yeah. Without further ado, let's get into the Hello World program. Yeah, so the Hello World program. So the objective of this particular like file is to, of course, go through the Hello World, but then also look at commenting. And commenting is important because in later sections where concepts may be a bit more advanced, comments will really help break down what we're doing and why we're doing it. And so I think it's useful to go through commenting near the beginning of the presentation. So yeah, so let's get started with the first component of this, which is the Hello World program. So, the objective of the Hello World program is to print out Hello World to the console when a particular piece of Python code is executed. And so to print things out in Python, we have something called the print command. So I would just do print like that. And then in these parentheses, I pass in whatever I want to be printed. So since I want Hello World to be printed, I'll start my string, hello world. And there we go. That's how you would write your hello world program. Now to execute Python code, this is another thing that I want all of you to take away from this. One way to execute Python code is always to just use this, the play button that comes with VS Code. But I think it's more useful if we actually look at how it's working rather than just using what's there. So for that purpose, I'll open my terminal because you execute code from the terminal. And from there, uh, so if I do ls, it'll show me all the files, all the folders that I have. So you can see it matches up with the folders I have here. And I'll navigate into the intro folder. So change directory, cd, section 0, intro. So now that I'm in my directory, if I do ls again, list directory, you'll see that I have access to the s03.py. So I have access to the file now. Now to execute Python code, all you have to do is Python. So just type in Python and then the name of the file, s03.py. And we can see it printed hello world. Now, just a quick note of caution: if you're on a Mac or Linux and you're using the default distribution of Python that comes pre-installed on your computer, then if Python doesn't work, what should work is something like this: Python 3 and then the file name. So that's just something to keep in mind there. And also another thing is that I mentioned that you would have to keep the file name after Python. Not necessarily. It's basically an absolute path or a relative path if you're aware of the concept. If not, just ignore what I'm saying. But if you know what that is, then yeah, it's Python and then the absolute path to the file, the Python file you want to execute, or the relative path. So yeah, that's that. Yeah, so now that we've covered the hello world part and the executing code part, let's look at commenting. So basically what commenting is a way to provide like some sort of like description of what you're doing inside the code itself. And why this is important is because it improves code maintainability. In the future, if somebody's looking at your code and is not able to tell what you've done, then if they can look through your comments, then they'll know exactly what you were intending to do. And that's why comments are really important, because if you have a lot of code without comments, then it can get really hard for somebody else to look at your code and know exactly what's happening. So let's quickly look at how you would comment in Python. So there's two main ways you can comment in Python. A comment can occupy its own line. So you can see up here, I have section 0, hello world. Comments begin with a pound sign. You can see how it's occupying its own entire line. There's no Python code on that line. It's just a comment. So that's one thing. And another way to write comment is on sort of like the end of a line that has code to the left of it. So for example, if I were to write a comment here saying, okay, I don't know, this prints hello world. So that's another way you can comment, where you can put it after the code on the same line as the code. So those are the two ways to write comments in Python. All right, so I think that's pretty much it for this section. Maybe before moving on to the next section, if anybody has any questions, if that's possible. If anybody wants to ask any questions, we can deal with that, and then we can move on to the next section. No questions? If not, then yeah, let's move on. All right, so next we're going to look at data types in Python. So let's start with that. Okay, so data types. So what are data types and why do we need data types? Well, basically, data types, data specifically, is something that we work with a lot in programming. When we code, we work with lots of individual instances of data, and it's useful to categorize these data into different types so that we know how to deal with them separately. Like, for example, if I have a name and I have an age, then those two are qualitatively different things. And data types reflect that, because the name is just like a string, which you can see at the bottom of the screen is a primitive data type, and an age is an integer. It's a number, right? It's not like a string like a name. And so it's useful to distinguish data into different types so that we know how to deal with it. And since Python is object-oriented, you can create your own data types from these primitive data types. So the primitive data types are the data types that make up all other data types. And so when starting out, it's useful to start out with the 4 primitive data types: int, float, bool, and string. And then once you're a bit more experienced, you can start creating your own data types and classes and objects and so forth. Yeah, so let's look at the first two, the numeric types. First two numeric types, int and float. So these two are collectively called numeric types because they both represent numbers. Int specifically, int represents whole numbers, so positive, negative, and 0. So exact numbers, no decimals, none of that, just exact integers. So as examples of that, negative 1000, 56, and 0. It's easy to forget about 0 when we're talking about integers, but yeah, it's good to remember that 0 is also part of that set. And moving on to float. Float is similar to integer, except it includes everything with decimals as well. So again, positive, negative, real numbers instead of whole numbers. And something unique about float in Python is that we can actually represent infinity in Python using float. And so the way you would do that is float, and then in the parentheses, pass in a string that says inf, and that will be infinity. Again, we'll look at this more practically when we look at some code, but yeah. And again, some examples are negative 9.81, 3.14, 1000.51 decimals. All right, so now let's take a quick look at what I just talked about. And so what I'll do is, since we talked about int and float, I'll show you what that looks like. So I'll use print and 1. So, and then print and, I don't know, 1.57 or something. So as you'd expect, if we print this out, let me navigate directory again, data types, Python s13.py. And so it prints those out. Now we want to see the type of a particular like literal, then what we can do is in Python, we have something called the type method. And so I can repeat the same piece of code, so I'll copy it. Instead of printing out 1, I'm going to print out type of 1. And we'll see what the type says. Type. Okay, now let's execute it again. And you can see that the first one prints out int, 1 prints out int, and then 1.57 gives out float. Again, this is because 1 does not have any decimal values after it. It's just an exact number, and 1.57 does have decimal values. So that's why that would work. And so yeah, that goes back to the int and float that we talked about earlier. So any questions about int and float? If there are any questions, I can answer them, or else we can move on to the next data type that we're going to look at. All right, we'll move on to the next one. So the next data type we're going to look at is the Boolean, or in Python, bool. So bools represent truth states. So it's either on or off. It's like a switch. It's either true or it's false. And these are useful when we're evaluating conditions with conditionals. As you can see, that's section 5 of today's presentation. So when we look at conditionals later, you'll see the utility behind Booleans. But yeah, it's basically like a switch. It's either on or it's off. And this is pretty useful in programming, as we'll see. Yep, so now let's take a quick look at how we would use them. So for example, let's do the same thing that we did earlier, where we're going to print out the type. So in Python, how you would represent true is with capital T, RUE. That's true. So let's quickly look at that one as well, s1.py. And you can see it prints out class bool because it's a Boolean. And of course, we can also do the opposite for this, which is false. So let's do Python s1.py again, and we get bool 2 times. And so you see that these 2 types are Booleans, and I'll just put a comment here. Type of Boolean literals. So that's Boolean types. Next, let's take a look at strings. Let's take a quick look at strings. So strings are, as I mentioned earlier, like for example, if I asked you your name, then what you would answer back to me would be a string. It would be your name. And so essentially they're sequences of characters. It's just individual characters put together in a specific order, and that together is a string. Now, in strings, if we have like a string and we want to access individual characters in that string, we have something called character indexing. And so this is something we'll also see in section 4 when we talk about lists, but we can access each individual element of a string, or in this case, each character of a string. And we can do this by basically a number is assigned to each character starting at 0. So the first character that occurs in a string will have the index 0. The next one will have 1 and so on. And what you see where it says len str, well, basically len is a function that returns the length of a string. So if I have ABC as my string, then len of ABC will return 3 since it's 3 characters. As you can see how if we're starting at 0 and the total string is len of string, that's how long it is, then the index for the last character will be len of string minus 1, since we start indexing at 0. So that's how indexing will work. We'll take a quick look at indexing when we look at some of the code that we're going to look at. There's also, to begin strings, we can use a single quote or a double quote. So for example, here we have both of these examples I've used single quotes, but as we'll see, we can also use double quotes as well, and that works as well. Now, useful methods. So since we are talking about Python and Python is object-oriented, we have many available methods to us that we can use on string objects. And 3 that we're going to look at today first one is len, second one is find, and third one is replace. Len, as I mentioned earlier, is about finding the length of a string. Find is basically if you have some sort of string that you're looking for in a larger string, if you pass in the smaller string to find will return the index of the first occurrence of that particular smaller string in the larger string. So we'll take a look at how this exactly works. And replace is, as you would expect, replace allows you to take one particular small string, and wherever that occurs in the larger string, you can change that with whatever you want it to be. And so we'll take a look at that as well. All right, so let's look at the code for that. So we'll start off with dealing with the len. So I'll just drop a quick comment, strings. So let's do print len hello world. Open my terminal again. I'll do Python s1 7.py, and it prints out 11 because it's 11 characters. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11. So it's 11 characters, and that's why it prints out 11 there. So that's a quick, that was a look at the len function. Let's drop a comment for that. Next one we're going to look at is the find function. So, all right, so let's let's drop a quick comment. So say I have the string hello world, and I want to replace world with, sorry, we're doing fine, I'm sorry. So let's say I want to find where world occurs in the string. But like right now it's just 2 words, so it doesn't seem like it's that big of a question, but strings can be hundreds of lines long. And so this is actually a pretty useful feature to be able to find where the first occurrence is. So in this particular case, let's look at how we would use it. So we would do dot, and then you can see VS Code is recommending find to me. So I'll click that, find. So I did the string and then dot find, and then I wanted to search for the substring world. So I'll do world. And yeah, let's take a quick look at what that would give us. So it prints out 6. So what is 6? Well, if we look at the string again, it's 1, 2, 3, 4, 5, 6. 0, sorry, 0, sorry. 0, 1, 2, 3, 4, 5, 6. So you can see that the particular substring starts at the index 6, right? And that's why it's giving me 6 back. If, for example, I did hello, you would see that it would give me the index 0. It gives me 0 because hello starts at the index 0. So basically what this will do is we'll take the substring that you're looking for, find the first occurrence in the actual string, and based on that, it'll return the index where the occurrence starts at. Now, this is all good, but what if the string that you're searching for doesn't exist? Like, for example, I'm searching for the word dog in the string. It doesn't exist, right? So let's see what happens. And returns -1. So yeah, so if you search for a particular substring in a string and the substring is not found anywhere in the string, if it's not found, then there is no first occurrence. And so it returns -1 to indicate that it was not found. So that's important to keep in mind. And then finally, let's take a quick look at the replace method. So using the replace function. Also, I think I'm saying method and function irreplaceably. And for now, yeah, that's pretty much true for you guys. So when I say function and method, I mean the same thing. So don't get confused, just in case. So now looking at the replace method, let's say I have the string hack the 7. Yeah, and so clearly this is incorrect, right? It should be 6. So what I can do is I can do dot, and then I can scroll down to replace, or I can just type it out. Dot replace. And then this takes two things in the parentheses. One is the thing that you want to replace, and the second is the thing that you want to replace it by. So since I want to replace this 7 with a 6, I'll do this. I want to replace the 7, and I want to replace it with a 6. And so this will take the 7 and make it a 6, because that's the second parameter. So now if I execute this code, you'll see that it's hacked the 6, because we replaced the 7 with a 6. And so yeah, those are the 3 main methods that we're going to look at for strings. And so that concludes the data types section. If anybody has any questions, feel free to ask. If not, we can move on to the third section on variables. Also, as a quick side note, you may have noticed that the section numbers begin at 0, and this is kind of a corny joke, but that's also related to like the indexing, how the indexing starts at 0. So oftentimes you'll see people making jokes about things of programming starting with 0 instead of 1, and that's also part of this. Yeah. If there are no questions, then yeah, we can start with the next section. So let's look at variables. Variables. So what are variables? Well, variables are things in programming that can have any value you give to them. So it's basically sort of like a name you give to something and then a value. So the name points to the value. So why this is useful is because oftentimes, like as we did before, we had the strings in the print function. And that was all good, but what if we don't want to print it? What if we want to use it for something else where we don't have access to it anymore? Once we do dot replace and we don't assign it to anything else, that's it. Like we're done. That doesn't really help us. And so saving data is actually something that's really useful because it allows us to use that particular thing that we saved in the future in other parts of the code. Specifically, internally, if we look at how variables work, variables are basically just stored on the memory under an alias. So on a portion of your memory, you like the variable name that you give to your variable, it's called an identifier. It uniquely identifies your variable. That unique identifier is basically a reference to a part of your memory in your computer, and that memory in your computer contains the value. So it's sort of like you use the variable name points to the location in memory, and the value stored at the location in the memory is the actual value of the variable. That's how that's implemented internally. So yeah, that's a brief overview. And below you have the standard, like what you search on Google, Wikipedia sort of definition to look at as well. All right, so let's take a deeper look at the syntax specific to variables. And so this is what the syntax is in Python. Python makes it very easy to work with variables. So what you would have here is variable name, so whatever name you want to get to the variable, equal to, and whatever value you want to get to the variable. So that's how that would work in Python. Again, don't worry, we'll look at an example in the next section. All right, so that's the syntax, but there are certain things to keep in mind because like you get to choose your variable name, but there are rules and restrictions on what you can and cannot use. So the first one is that you can only use alphanumeric characters and underscores. You can't use like symbols like the copyright symbol or like and or pound or something like that. That's not allowed. You can only use alphanumeric and underscores. The second one is you must start with a letter or underscore. You can't start with a number. I guess this goes without saying, but as per the previous one. And finally, the last part is about case sensitivity. So we'll take a look at this in the next coding tutorial. But basically, even if you have the same like set of characters in the same order, but if any of the like case is different for any of the letters involved, that becomes a different variable. So for example, if I have the variable age, AGE, everything in lowercase, and I have a variable AGE, everything in uppercase, those are recognized as two different variables. And so that's important to keep in mind. Adopt a uniform style for naming your variables and stick to it. Because if you haphazardly name your variables, it can get really confusing as to what you're doing, both for you and for any other programmers that are working with you. Yeah. So, right, so let's take a quick look at that in code. So as I did before, I'm going to create a variable with hack the 6 as the value. So here I have a variable named a and has the value hack the 6, which is a string. And so now what I can do is I can print the variable using print a. So if I open my terminal, clear up my terminal, I'm going to change directory. Don't worry about changing directory. That's not important. The important part is executing Python code. So you can ignore all the CD stuff. So Python s23.py, and it prints out hack the 6 because hack the 6 is a string stored in the variable a. So that works. Next, let's take a look at some integral types or numeric types, I'm sorry. So let's create an integer called b with value 1. Let's create an integer called c with value 2. And then we can print out b plus c. So let's see what this gives us since these are integer types. And it gives us 3 as we would expect. 1 plus 2 is 3. Yeah. So now another thing that I'd like to end this section on is that your variable names should be very specific to whatever they're referring to. Giving very ambiguous variable names like A, B, and C, like that works in tutorial, but don't do it in real life because nobody will have any idea what you're doing. And so it's always good to give specific variable names. So like an example here would be greeting equals hello world. And if I print greeting, it prints out hello world. And so in this case, since I said greeting, anybody that looks at it kind of has an idea of what it's for and what it's about. If I just named it something like D, you would have no idea what this is. And that would be very confusing for any of the programmers that are working with you. So it's obviously, oh, and I realized I forgot to comment. So I'll quickly do the commenting, but also keep in mind that your variable name should be pretty precise as to what their purpose is. So I'll just drop a few comments in, printing out hack the 6, performing addition, and naming variables with a good name. Okay, yeah, so that's pretty much it for the variable section. This is pretty important because we'll be using variables throughout the rest of the presentation. So it's important that you have a grasp of what we're doing here. So if you have any questions, feel free to ask, and then we can move on to the next section because this is pretty important for the rest of the presentation. So if anybody has any questions, feel free to ask. No questions? Okay. In that case, we can move on to the rest of the presentation. So next we're going to look at I/O, and I/O is a cool way to say input and output. And yeah, so we're going to look at input and output. And so based on what we've already looked at, you'll notice that we've already looked at output. We've already looked at how to print stuff out, right? So we already have experience with how to output things. And we saw earlier in like the very beginning of the presentation that you can print out literals. Literals are basically just exact values. Like 1 is a literal, 5 is a literal, true is a literal, hello is a literal. And so that's what literals are. We saw how we can print those out. And then we also saw in the previous coding tutorial that we could also print out variables, because remember I assigned hack6 to a variable called a, and I printed that variable out and it worked, right? So we can also print out variables. And so as we've already looked at, we can print out literals and variables. So let's take a quick look at the coding section, coding tutorial for that particular slide. And yeah, so let's print out literals, print out 1, so that's a numeric type. Let's print out a Boolean type, true. And let's print out a string. So that would be something like, let's do Python is awesome. So now we're printing out literals. So we looked at numeric types, so we're printing out a numeric type. We looked at Booleans, so we're printing out Booleans. And we looked at strings, so we're going to print out strings now. So let's quickly execute this code. I need to change directory again. Don't worry about that. Clear. We can do Python s32.py, and it prints out all three. And so we see that you can print out literals. Now that we've looked at literals, let's look at variables, as we did in the previous section, but I think it's just cool to go through it again. So let's start by assigning a variable. So I'm going to stick with a, very simple name. Python is awesome. And in theory, this should, whatever I'm going to do next by printing a should produce the same effect as this. So let's see if that happens. Print a. We do Python s32.py. You can see that both produce identical results, and so indeed both work the same. So yeah, that sums up the literals and variables part of it. Let's move on. Now we look at input. Now that we've already looked at output, we can look at input. Input is a bit more involved than output, but that's okay. We're going to cover it in detail. All right, so input. So in Python, you take input by calling the input method. And what I mean by that, I'll show you in the coding tutorial after this, but basically, when you call the input method, it gives you back whatever the user types in, and it cuts off any of the white space after. So for example, if I type my name and I'm done with my name, the rest of it will just be like blank space, right? So what input will do, it will chop off all that blank space, and it'll just keep like whatever my name would be in that case. And so yeah, the trailing white space is called out the string before it is returned. And it's also keep in mind that input only reads one line. So if you have multi-line input, you're gonna have to explore other options. But for most simple use cases, input works just fine. It takes the entire line and stores that as the result of whatever the user inputted. And yeah, and another thing to keep in mind is that input, when you use without anything inside, so without, like, you know how in print we put stuff inside the parentheses? In input, you can also put stuff inside the parentheses. And when you do that, it's like asking a question. When you ask somebody a question, you don't just, just blank stare at them, right? You actually ask them a question. And so if you pass in a string into input, you'll actually be asking a question. It won't just be like, the computer just waiting for you to type with no sign of, give me something. It'll be like you can specify what you want the user to know before they type in whatever they type in. So what I mean exactly by that, I'll go through, but that's basically what the input method does. So let's take a quick look at how this would work. So let's look at input. So we're going to print out input. So you see how this works. Let me make this a bit bigger. Clear s34.py. And so you see it's just waiting for me. It's just blank. So you see, this is not very intuitive if you're like a normal human. Like, it would be very useful to have something where you could ask a question or something and then expect a response. And so we'll see how to do that. But for now, let's just say, I don't know, hack the 6. Oops, sorry, misspelled that. But you can see it printed it out immediately. So now that I showed you guys how kind of dull it is to just take input on its own, let's take input with a message. So let's say input, but then inside I'm going to pass in a string. That string is going to be, what is your name? Yeah, so let's try this. Python, whatever, first doesn't matter. And then ask me what your name is. So first it took the input Python, which I typed in, it printed it out to me, and now it's asking me what's my name. So I can type in Krish, but you'll notice that it's like next to each other. It's adjacent. There's no space in between the input and what you type in. We'll fix that in the next step, but for now, let's just do this. And it prints out Krish because that's what I typed in. Now to fix this problem, what you could do is if I just type the same thing again, input, what is your name? What we can do to provide some space and sort of like breathing room for the text is we can drop a space in after the quotation, after the question mark. So if we execute the Python code again, you'll see what that does. So I do Python, Krish, again, it's looking kind of terrible, but now you see there's a space there, and so it doesn't look as hideous as before. So yeah, that's how you take input. Important to keep in mind that sometimes you might want to put space there so that it looks a bit more readable to the users that are using your application. So yeah, that's that. That's how you take input. Now let's move on to the next part. So now we looked at variables, right? Well, we can assign what we get from input to a variable. In the past exercise, we saw that I was just sort of printing out as I inputted things, and I wasn't really saving them for any further use. Of course, that's not very useful in the real world, right? So you want to save your results to variables and then use those in the future. Yeah. So again, saving the result in a variable makes it accessible in the future. You can use whatever the user typed in any other further part of your code, and that's why it's useful. So let's take a quick look at some code to demonstrate how you would do variables with this. So for example, I can say name equals input. What is your name? And then as I mentioned earlier, drop a space in. That will ask the user for their name. And then let's do something like favorite food equals input. What is your favorite food? And then another space. And then we could do something like print name. And then in print, if you want to type in multiple things together, you can use a comma. I didn't mention this earlier, but it's a bit of a more advanced concept. Just take it for now. But yeah, so if you have a comma, you can add multiple stuff. So I can say name likes favorite food. And so a couple things to notice here. First of all, I'm using variables inside my print statement, which is cool. But note I'm combining my variables with literals. So likes is just a string, right? But I'm combining that with other string literals in the form of name and food. And so this is going to be really interesting when we execute it. So let me just drop in a few comments. Asking user for a name, asking user for their favorite food, printing out their favorite food. Okay, so now let's see what this gives us. So I can do Python s36.py. What is your name? My name is Krish. What is your favorite food? Pizza. Krish likes pizza. And so that's how you can combine variables, input, print everything together into one. So that's how you would do that. Any questions so far? This is a bit more involved in the previous section, so if there are any questions, I can take them right now. If no questions, we can move on, but if there are any, feel free to let me know. All right, so let's move on. I can see we're a bit tight on time, so I'm going to speed up a bit. Okay, so now let's get to integers and typecasting. So we saw earlier, you could take inputs from with using the input method, but you might have seen that it only returns strings as the result, right? Like whatever the user typed in, it would return that as a string. Even if I typed in a number, it would return that number as a string. And so that's not really useful to us, right? Like what if we actually want to get an integer as input? Well, how would we do that? Well, there's something called typecasting, which is basically converting one data type to another. So for example, if I have 17 as part of a string, and I want to take that 17 and make that an integer, what I would do is I would pass in that specific string into this int, parenthesis, and another parenthesis. And between that, I would pass in whatever it is I want to convert. And so this is useful because, of course, not we don't always want to work with strings. We want to take input of numeric types as well, right? So that's important for that reason. And to get a bit more technical, this is basically using the constructor for the integer type. And you can do this with other types as well. You would just be passing in different types into the constructors for different other types. So for example, if I want to convert a string to a float or something, I would pass into the float constructor, which would basically be the same thing, except instead of int, it will be float. So yeah, that's basically that. Other than that, I think we should just get into code. We're running a bit tight on time. So yeah, so age is equal to input. I can say, what is your age, space, and this will give me a string. So if I print out type age, let's also print out age, why not? We take a look at this, Python s3 8.py, oops. And it prints out that, so I'm gonna say, I don't know, 17, class string. So it's taking input as a string, right? And we don't want that. So what we can do is, we can do int, and then int on that side as well. So now if we do that, now we do the same thing. 17. I'll print out 17. I'll print out class integer. So now we've successfully converted our string to an integer. So now we can interact with it as we would with an integer. So I can say something like print age plus 5. I don't know. Since it's an integer, we can do integer operations. So 17 class int and then 22. So yeah. If it was a string, you wouldn't be able to perform, arithmetic operations with it because that doesn't make sense with a string. And yeah, I think that's pretty much it for this section. So we looked at, as a quick recap, we looked at output, then we looked at input, then we looked at assigning input to a variable, and then finally we looked at typecasting from string to integer or float or any other type, to be honest. So yeah, that's pretty much it for input output. We can quickly go into lists. So we're a bit tight on time, but if there are any other questions, I can answer them right now. Feel free to ask if there are any questions. No? All right, so then we'll just move on. So let's start out with lists. And so lists are basically a way to store multiple values at once. And this is useful because, for example, let's say I'm storing usernames for my application, for all the users of my application. Well, it doesn't make sense to store each individual username as its own variable, right? That would be cumbersome. If there are a million different users, I would have a million different variables, and that's impossible to maintain. And so in that case, it would make sense if we had some sort of like one place where we could store multiple variables, and lists help us do that. So yeah, so the motivation for that is if we have many different variables, then it would be really hard to store them individually. So it would be helpful to store them together. And another reason why we want to use lists is that a lot of data is just grouped by nature. Like, as I mentioned, right, like if you have usernames together, it's kind of hard to work with that if they're different variables. But if they're together in one place, it just makes sense if they're together because they're representing the same thing. They're all representing usernames, right? So it makes sense to keep them together. And the final reason is when we look at looping in section 6, if we get there, when we look at looping, you'll see the benefit that lists provide, because if you have multiple variables with looping, you can just quickly access all of them like in one like loop, right? So don't worry about that. We'll learn more when we look at the section on looping, but that's that. And this is sort of the more technical definition of Wikipedia again about what an array is. In other languages, they call them arrays. In Python, we call them lists. Pretty much the same thing for all beginner purposes. So yeah, that's that. Now let's quickly jump into the rest of the contents. And so let's look at the syntax for how you would define a list. So a list is basically defined by 2 square brackets. Oops, sorry. 2 square brackets. Yeah, 2 square brackets, yeah. So it's defined by 2 square brackets. As you would with a normal variable, you do variable name equals and then square brackets. Another way to do it, as we saw, remember when we used int to cast stuff? Well, we can do that with lists as well. If you leave it empty, you'll just you have the same result as you would if you did it with square brackets. So I can do list and parentheses, of course, and that will give me the same thing as this. And so that's that. And so as we looked at with strings as well, there's also many useful methods that we have with lists. And the 4 we'll look at is len, append, insert, and remove. Len just basically gives you the length of the list, the number of elements in the list. Append basically lets you add an element to the list. Insert lets you add an element to the list at a particular index. And remove helps you remove a certain value from the list. Like if you have an unwanted value in the list and you want to remove all instances of that unwanted value, you can just remove and get rid of that. And also one final thing to note is that unlike in other languages, in Python, lists can store variables of different data types together. Like for example, in C or Java or whatever, you can't store integers and strings and everything together in one place. But Python has a flexibility that allows you to store all of them together. So you can have a list where you have numeric types, bools, and strings all together in one list. So that's something unique to Python, and I think it's good to know. Now let's quickly take a look at the coding section for this. So let's quickly begin, let's begin by just defining a list as a variable. So we'll say this is a basic application. First list, my variable name is equal to list. Or what we could also do is actually, let's do this. Yeah, you could also do this. And then we can also print out the type of first list so I can show you what it says. Yeah, and yeah, that's pretty much it for now. Let's also print out first list as well. Oops, typo. Python, navigate. Lists, oh, oops. Let me just clear the terminal and then let's do Python s43.py. And it says class list. So yeah, list is its own data type. And then again, when we print out first list, you see that it's just square brackets because it's empty. It doesn't have anything inside it. And so that's why it shows up as just square brackets because there's no contents. We haven't added anything to the list. Yep. Now that we've looked at how to create a list, let's look at some of the methods that we talked about before. So first let's use the append method to add things to the list. So I'll say first list dot append, and I'll say let's append the value 1. And let's do that again, but now let's add 2. Now if I print out first list, you'll see what happens. And it prints out 1, 2 because I added 1 and then I added 2. So doing dot append 1, dot append 2, I added 1 and 2 to the list. So that's how you add things to the list. So now that our list has elements in it, let's look at the len for it. So instead of doing this, I'll do print len, and then one more parenthesis. And so it prints out 2, because there's 2 elements in my list, 1 and 2, because I added 1 element and I added a second element. When I print out the length of my list, it gives me 2. So that's how len and append would work. Let's take a quick look at the other 2 methods, namely remove and insert. So now let's look at, before we look at the methods, let's look at a more complex application. So you could start a list like this as well. So A equals 1, 2, 3, combined data types, why not? False, yeah, something like this. I'll also pass in a string, why not? Half is 6. So you can also start off lists with elements in them. You don't just have to start them off as being empty. You can create lists like this as well. And now let's print the list so that we can see what's in the list. So I'll just do Python s4.py, and it prints out the list with all the elements in it. And so you can see that this is also a way we can initialize a list. Now let's look at the insert method. So we can say if we want to insert a new element, so we can do a.insert, and the insert takes 2 parameters. It takes the index, because remember I mentioned that lists are, actually I think I might have not mentioned that, but in any case, basically what happens in the list, just like as with the string, the elements are indexed from 0 to len of list minus 1. Everything is indexed like that. So I can actually add an element at a particular index. So say I wanted to add something at the 0th index. So I can say 0, I can say new element. If I print out A, you'll see that it added new element. So new element was added to index 0. So you can see how insert works. Now, let's say I want to remove an element, so I can use the remove method. So I'll remove the newly added element. So I can do a.remove, and I just pass in the value I want to remove. In this case, I want to remove new element. So I print a again, do that again, and you can see that when I printed it out first, it didn't have a new element in it, right? Actually, let me clear and then do it again. Yeah, so when I printed it out first before adding the new element, you can see that it doesn't have the new element. Then I added the new element, so you saw the new element, and then I removed the new element, so then it disappeared again. And yeah, so that's basically the three methods we're going to look at for lists. Sorry, four methods, I think. Yeah, so that's basically that. All right, now, as I mentioned earlier, list indexing. So let's take a closer look at list indexing. And so, as I mentioned earlier, lists are indexed in the same way as strings are. So from index 0 position, so the first element of the list having index 0 to the last element in the list having index len of list -1. And yeah, so we can make use of indexing like that. And to make use of indexing, you would use something called the subscript operator. So it sort of looks like the initialization for a list, but it's different. Oops, sorry. So here's an example demonstrating how you would do that. So say I initialize a list with elements like I did in the previous coding example, a equals 1, 2, 3, 4, 5. I wanted to print out a of 0. So I would do a, and then brackets, and then inside I'll put 0. So that would let me access the 0th position. And the 0th position contains a 1, right? So basically that will print out a 1. So I put 1 comment. And so that's how indexing is going to work. So let's take a quick look at an example for that. Sorry if I'm going a bit fast, I'm just trying to cover as much as I can. So accessing list elements by index. Let's create a list, a equals 1, 2, 3. This is basically the same example from last time, I think. Let's do Python s46.py, and it prints out 2. So why does it print out 2? So it prints out whatever is there at the first index. Well, since indexing begins at 0, 1 is going to actually have the index 0, and 2 is going to have the index 1. So when we print out the element at the first index, it's going to print out 2, which it does. So that works. Now that we've looked at accessing list elements by index, let's look at modifying list elements by index. So for example, I could say a1 equals something like 500. So take the first element at the first index in a and make its value to 500. So now if I print out a, you'll see the change. Let's print a before and let's print a after so we can see the change. And so we have 2 from the initial list, and then I'm printing it out just to show you what the list looks like before I modify it. And then I modify it, and so you can see how the second element changed to 500 because I said the element at the first index at a needs to have the value 500. So Python went ahead and changed this value in the list. So that's how accessing and modifying list elements by index would work. Yeah, so that's pretty much it for lists, I guess. I don't think we'll be able to cover everything today, but I can provide a link containing all the code so that if you want to look at the code after as well, you can do that. So at the end of the presentation, I'll give you guys a link for the code in this presentation, and whatever we can't get to, you can look at there. So let's look at conditionals now. Let's begin with, again, some sort of definition. So basically, a lot of times we want to control the way our program works in the sense that we want it to be responsive to different variable values, so that if some particular condition is there's some particular scenario happens in our code, the program behaves a certain way. If some other condition happens in our code, our program behaves some other way. So basically to make the program a bit smarter and a bit more responsive to the way we might want it to behave in. And that's basically referring to the idea of control flow. We basically try to control the flow of execution in a way that suits our needs. And so it might not always just be from top to bottom, right? We want to see and adapt to whatever the values of the variables may be and let the program behave accordingly. So that's the point of conditionals. So let's take a look at that. Again, here's a quick look at the Wikipedia definition for those interested. Let's look at S5.2. Yeah, so the first conditional statement we're going to be looking at is the if statement. So if statements are used to check whether a particular condition is true or not. And remember how I mentioned earlier when we covered data types that we'd be coming back to this and talking about the Boolean data type? Well, the Boolean data type is very important when it comes to conditionals because the Boolean data type is basically going to help us determine whether or not we should perform an operation or not. So in this case, so for example, if we have if and then whatever we want to do is true, that condition is valid, then we go ahead and execute the code below the if statement. If it's not valid, we skip the if statement because that condition was not satisfied. And so the condition being satisfied or not is like a switch, right? Either the condition is satisfied or the condition is not satisfied. So that's where the role of the Boolean comes in. Let's look at the syntax. So the syntax is if something. So in this case, the something is basically the condition, the Boolean condition. If that condition is true, the code underneath the if statement, the do something, will be executed. If not, then it'll just skip the code. It'll skip the code underneath the if statement, basically. And so here we have, as I mentioned here, the something is a Boolean condition that is evaluated. So let's look at the code for this. We're going to look at two important operators here. The first one is called the equality operator. The equality operator basically checks two integers and checks if they are equal to each other. If they are equal to each other, then the if statement, if they're equal to each other, then the condition evaluated is true. The Boolean returned is true. If they're not equal to each other, the Boolean return, is false. So let's look at the syntax for that. So I'll define a variable really quickly. A is equal to the integer 4. Then I want to check for equality. If A is equal to the integer 4, print out, yay, I found the number. So when you want to check for equality in any programming language, basically, you would use a double equal sign. In Python specifically, it does differ with language a little bit, but in Python, if you want to check for equality, you use double equal sign. The reason we don't use single equal sign is because if you look back here, single equal sign is used to assign values to variables. So we can't reuse that, otherwise there will be a conflict in definition, right? So that's why we use double equal sign to indicate that we're looking for, or we're checking for equality. So now let's execute this code and see what happens. So we have Python s5.3.py. Oh, oops, sorry, I did not change directory. Section 5 conditionals. I can do Python s5.3, name of the file, .py. And it prints out, yay, I found the number because this condition is satisfied. A is equal to 4. And so when I check for if A is equal to 4, since A is equal to 4, it returns true. So this part returns true. And so I can say print, yay, I found the number, and the code executes because the condition is passed. Now note that this actually returns a Boolean, right? So if I were to say something like if true, then this will always work. This will always work. If I say if false, this will always fail. It'll never work. And so C doesn't print out anything because if false will always be, like, it will never be a valid, the condition will never be true for the code below to execute. So now that we've looked at a condition where it is valid, let's look at a condition where it wouldn't be valid. So let's do in the same code actually. If A is equal to 5, this is not supposed to print. And that's true because we're checking if A is equal to 5 when we know that we've assigned A equal to 4. So let's quickly look at this. As you can see, it prints out, nothing is printed out because this condition is not evaluated to be true, so the code is never executed. Now that we've looked at the equality operator, let's look at inequalities. Inequalities. Okay, so since we have A equal to 4, let's say we want to check if A is less than or equal to 5. Again, this will evaluate to a Boolean condition, so we have A less than or equal to 5, and so basically be true or false, and in our case, since A is equal to 4, this will evaluate to true since A is indeed less than or equal to 5. So you can say print, yay, found the range of the number. So let's see what this prints out. So it prints out the second string, but again, note that it doesn't print out the first one because that condition is false. This condition is satisfied, however, in contrast to the previous one. So you can see it prints out, yay, found the range of the number. Again, as we looked at a valid, invalid example for the equality, let's look at an invalid example for the inequality as well. So if I say A is less than or equal to 3, you know this is going to be false, right? Because A is equal to 4. 4 is not less than or equal to 3. It's greater. So again, we can do this is not supposed to print, And how about this? I'll get rid of this so that we don't confuse the two print statements. So let's look at yay found the range of the number, so it prints out this, but it does not print out this because, again, it's not supposed to print because this condition is evaluated to false and it doesn't execute. So that's that. Yeah. And moving on, I think we may be a bit short on time. All right, I'll just try my best to go. Oh, how do you handle errors in Python? Actually, how about this? Let me create an error and show you what it looks like. So for example, let's say I forgot the semicolon here. Let's get rid of this. I just want to show you the error. So let's say, okay, fine, let's define the variable a equal to 4. And let's say I forgot the semicolon. Semicolon is required, but say I forgot it. Let's see what happens. s5.3pi. And you can see it says syntax error. So Python has a number of like errors that it like it's basically well, I mean that's a bit advanced, but what I'll say is basically there's different types of errors. So there's index errors, zero division errors, syntax errors, different types of errors like this. And usually what you can do is if you're confused about what the error actually is, just copy this error message like this, and then you can just paste into Google and just look at the first couple results, and the you should be able to tell what exactly the error is about. But yeah, that's how you would handle errors in Python if you do come across them. All right, so that's that. Okay, let's move on. Let me just undo the incorrect changes. All right. Okay, so moving on to the rest. Else. And so we saw with if statements that if a certain condition was true, you could execute a piece of code, right? But what if you have a situation where it's like you want to execute, if this condition is true, you want to execute this piece of code. If this condition is false, you want to execute some other piece of code. Well, basically, else statements allow you to do that. So basically, in this case, you can see if something, then you do something. But if that condition evaluates to false, the basically the condition, the flow passes to else, and do something else is executed. So if you had a check, the check failed, and it would execute this thing under the else. So let's take a quick look at that as well. So same thing, a equal to 4, if a equal to 5, print found number, else print did not find the number. So basically we know for a fact that this is going to evaluate to false. A is not equal to 5, so this is going to be false. So this line is never going to be executed. Instead, it's going to jump to else, and it's going to execute print did not find this number. So let's see what this prints out. Python s5.py, oops, s5.py did not find the number, because since this condition evaluates to false, it automatically jumps to else, and we print out this part of the code. So that's how that works. Any questions so far regarding anything I covered? Because I think we're just about out of time. No questions? 1 second. All right, so if there's no questions, then I'll finish up this section. How about that? Okay, so now let's look at elif. So when we looked at if statements, we saw a situation where it was basically we're only checking for one condition and then one code alternative. Else was a bit more advanced, where we had one check code alternative code, and then if that condition was false, another code. So basically, we had two alternatives for what code would be executed based on the condition. But say there's there's more than two alternatives. What if I'm checking multiple conditions at once? Then how would that work? Well, basically, that's where elif comes in. So we can use elif when we want to choose more than one code alternative based on different conditions. So let's look at some of the syntax for this. So again, as you would expect, it's if something, do first, and then elif, second condition, do second, and then you can do as many as you want in between. That's what the ... is. Elif nth condition, do the nth alternative, and then finally you can end with the else statement. So if none of the checks above passed, you go on to else, and then that's it. There's also something to keep in mind that when you're using elifs, you don't actually have to use else. Else is optional. Well, I mean, else is always optional, but Just because I mentioned it in this example doesn't mean you have to use it. I've only mentioned this example to show that you can use it. You don't have to. All right, so that's that. Let's look at the coding example for this. So let's try a different variable name B. Very creative. So let's check some conditions. Check some conditions with let's check conditions, why not? If B is less than or equal to 0, print B is a negative number. And what if it's not a negative number? Well, we can do elif. Elif B is equal to 1. We know for a fact that if some code is coming to this part of the this elif statement, then we know that it's going to be greater than 0, because if it was less than 0, this if statement would have caught it already. So if elif B is equal to 1, print B is equal to 1. Then you can do another one, B, print B is equal to 2, and then we can use an else. Else, print B is greater than or equal to 3. So let's look at what this outputs, Python s56.py. And you can see it prints out b is equal to 1 because the value is indeed 1. Now to spice this out, what we could do is we could say input, and since it's an integer, we could pass it into an int constructor. And now, let's actually pass in some message as well. Enter an integer, colon, space. So let's do that. Enter an integer, let's say -5. It prints out b is a negative number because this this part of the code is triggered. Let's say 2. B is equal to 2 because this part of the code is triggered, and I already showed you what happened if b is equal to 1, and you can assume likewise happens for the else. So that's that. So that basically concludes the conditional section. Just a second. So if there's any questions, I can answer those right now. So if anybody has any questions, I haven't got any questions so far, which is kind of weird, but if there's any questions, then I can answer them right now. One second. Okay, so that's pretty much it for the conditional section. We can move on to the next section just really quickly. One second. Okay, how about this? So I was a bit worried about the timing since we went over time, but I'll just speed run the rest of the presentation. So yeah, we can cover the rest of it. So there's only one section left. Section 7 is kind of optional. Section 7 is more of sort of like a exercise for all the contents of the presentation. So how about this? Let me just give you guys a link to the code so that if you have to leave right now, then you have access to all the material. And so since you have access to all the material, you can check out the 7th section, and you can try the exercise on your own after this presentation. So that's that. So if anybody has to leave, that's okay. I've given you the link with all the materials, so you have everything you need. Let's quickly go through the last section. I'm going to go really fast. But basically, loops are a way to repeat a certain piece of code multiple times. Loops enable something called iteration. Iterations are when you repeat something over and over again. It's like a process of repeating something. And this is useful because when we use them with lists and other iterable objects in Python, it's very easy to work with loops. This is actually, when group the conditionals, that's what I was going to say. When we group the conditionals, different iterations can behave differently based on the value of the variable you're accessing each iteration. And so, if you're repeating a certain piece of code multiple times, you might assume that, it's just doing the same thing over and over again, but that's not necessarily true because you can have conditionals and stuff, and so it'll behave differently in each iteration. That's that. The first type of loop we're going to look at is a for loop. For loops are used when the number of iterations is known beforehand. So when we know we're iterating a certain number of times and in sort of like a definite space, we can use something called a for loop. And so this will be the syntax for that: for looping variable, whatever you want to call the variable, in something. So the something here is like the object that you're working with. So something like a list or any other iterable object in Python. So yeah, so for looping variable in something, whatever it is, you do something in your code. And as I mentioned, yeah, it can be a list or a range of numbers or any iterable really. So let's quickly go through the code for this. Let's create a list so that we can iterate through it. Equals, oops, 1, 2, 3. For number in A, so number is my looping variable, A is the list, print number. So I can do Python, actually let me change directory. Python s63lpy, and you can see it prints out 1, 2, and 3. 1, 2, and 3 for each number in A. So that works. That's pretty much it. Let's go to the next part of it. So as I mentioned, you can also iterate through a range of numbers, not necessarily just through like a list or something. You can also iterate through a range of numbers. And how would you do that? You can do that using the range method. And so basically the range method, what that allows you to do is if you pass in two numbers, x and y, it'll start iterating at x and it will go all the way up to y minus 1. So that's why, I've used the curly parenthesis there from math, if you remember, where square brackets are included in the range and parentheses are not included in the range. And so that applies in this case. And now something to note is that if x is 0, so the first number you're using is 0, then it's optional. You can get rid of it altogether and it will work the same. So let's take a quick look at that as well. So for num in range, let's say 0 to 10. So instead of something, I passed in this range method, print num. That's actually like, let's do less numbers. Maybe that's more readable. s6.5.py. And you can see it prints out 0 through 4. So 0, 1, 2, 3, 4. Notice it stops at 4 because it goes all the way up to y minus 1, so 5 minus 1. And now that I started with 0, if I get rid of 0, you'll notice that the same code, it produces the same output. So you can notice 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. As I mentioned, if your first number is 0, you can omit it altogether, and yeah, it will work just as you expect it to work. So that's that. Let's quickly go over the last couple panes. So now we've covered the for loop. Let's look at the while loop. So the while loop is where the while loop fills a deficiency where the for loop is lacking. Basically, in for loop, you need to have a definite number of iterations for it to work. While loop can be used when the number of iterations is not known beforehand. So, for example, some sort of condition or something where you don't really know for sure when it's going to be true or false. You just have to keep trying until it is false. That's when a while loop is really useful. And so syntax is pretty simple. While the condition, do something underneath. So let's take a quick look at the codes for that. So as I mentioned before, you can use inequalities and equality checks as conditions. So let's try that. So let's say while num is less than or equal to 30, print num. So while num is going to be less than or equal to 30, it's going to print num. Num is 5. And we're going to increment num. So we're going to say num is equal to num plus 5. So we're going to say take num, increase it by 5, and save that back into num. So let's look at what this prints out. So you can see it prints out 5, 10, 15, 20, 25, 30. It's going to print out 5, increment it by 5, then check the condition again. So 5 plus 5 is 10, so 10 is less than 30. Prints 10, 15, 15 less than 30, prints out 15, does that over and over again. And then finally, when it gets to 30, num's going to be 30. It's going to say 30 less than 30, true. Print 30, 30 plus 5, 35, 35 less than 30, false. So that's false, and so that's where it exits the while loop. So that's that. And something also to keep in mind is the idea of an infinite loop. So I'll just get rid of this temporarily. Infinite loop. So this is what happens if, for example, if I did while true, print hello world, the condition is never going to be false. So it's going to keep on looping until infinity. So you can see it keeps printing. So I can do Control C, keyboard interrupt, and clear. And again, this is like a very literal example where it's while true. It may not exactly be like while true exactly. It could be some sort of faulty condition, some sort of bug that causes it to keep on going and going and going. And so you should try to avoid doing that because that will use up a lot of resources unnecessarily and is not very productive. So yeah, that's pretty much the looping section. The last part is just the concluding project. I can quickly go over it. This is basically, this problem was taken from LeetCode, but then I kind of modified it a bit. It's basically the Fizzbuzz problem, if you've heard of it, where given a range of numbers, you have to go through that particular range and you have to follow these rules and create an answer array. So since we're already over time, I guess, I'll leave this as an exercise to anybody that's interested in doing it. The code for this is available on the GitHub. If it's not, I'll upload it just after this presentation. So it will be there for you to look at once you're done. But yeah, other than that, yeah, that pretty much wraps up Intro to Python, this workshop. Thank you for coming.
Thank you so much for hosting this amazing beginner-friendly workshop, Krish. I hope everyone here learned something new and that we're able to see you implement this in the projects that you'll be submitting this week. Just very last minute, is there any questions for him before he leaves? I take it as silence is gold. Everyone is good. Again, thank you so much, Krish. And happy hacking to everyone.
Thank you guys for attending. Thank you.